Okay, 3-2, properties of parallel lines. So now we have parallel lines L and M. We have the transversal T that cuts through them. So if we know that angle M is 105 degrees, what is the measure of angle 2? Well, they're a linear pair, so angle 2 has to be 75 degrees. And then if I look at 2 and 3, they're a linear pair. So that makes 3 105 degrees. And then angle 4, again, would be 75 degrees. So if I was to take this line and those angles and slide them down here to angle 5, this would be 105 degrees. Slide down angle 6 would be 75 degrees. Angle 7 back to the 105 degrees. And angle 8, 75 degrees. These angles with parallel lines will be the same as these angles. So then that sets us up to do a whole bunch of theorems. And all these theorems start with if a transversal intersects two parallel lines. And when we intersect two parallel lines, then alternate interior angles are congruent. So if we look at our alternate interior angles of 4 and 6, they're both 75. 3 and 5 are both 105. They're going to be congruent to each other. If I look at my same side interior angles, so 4 and 5, those two angles are supplementary. So if a transversal intersects two parallel lines, then same side interior angles are supplementary. It's my SSS theorem, same side supplementary. And same with 3 and 6, they are supplementary because they're same side interior angles. So let's look at our corresponding angles. 1 and 5 are corresponding. They're congruent. 2 and 6 corresponding and congruent. 3 and 7 are congruent. 4 and 8 are congruent. So when a transversal intersects two parallel lines, then corresponding angles are congruent. Last but not least, alternate interior angles. We look at alternate exterior angles. We already did the interior. Exterior of 1 and 7, they're congruent. 2 and 8 are also congruent. So anytime you have alternate interior angles from your parallel lines, alternate exterior angles are congruent, alternate interior are congruent, and corresponding are congruent. The only one that's not congruent is same side interior angles. They are supplementary. All right, so if we have a proof, the proof is going to use some of these theorems. And in the proof, we are given line A is parallel to B. So we mark line A is parallel to B by putting little arrows on it. That's going to give us a bunch of information. Angle 1 is congruent to angle 4. So we mark those being congruent to see that what we can end up with. And we are asked to prove angle 2 is congruent to angle 3. So those two being congruent. So to make a plan, sometimes we look at our drawing and get a whole bunch of information immediately. So if I look at A's parallel to B, I have parallel lines. I have to talk about angle 1, 2, 3, and 4. So with my parallel lines and this first transversal, what do I know? In that section, I have angle 1 and angle 2, and those are same side interior angles. They must be supplementary. So when our lines are parallel, same side interior are supplementary. We can abbreviate it. So angle 1 and angle 2 are supplementary. If I look at my other transversal over here, I have, when the lines are parallel, same side interior supplementary, and my angle 3 and 4 are supplementary to each other. Okay, so now I've talked about everything that the parallel lines have given me, so now I write down angle 1 is congruent to angle 4 given. And now, looking at this information, I have to go back and think about what I already know. And there was a theorem that we had that said if two angles are supplements to congruent angles, so if two angles are supplementary to two congruent angles, then the angles are congruent. So if I look here, I had angle 1 was supplementary to 2, 3 was supplementary to 4, but they were two angles that were supplementary to the two congruent angles, so angle 2 is congruent to angle 3. Because they were supplementary to congruent angles, the other two angles have to be congruent. And we've done our proof. With proofs, you just have to go from your given, go into your next information, and finally get down to what you're asked to prove. It takes a while to get used to them, and you're proving something. It's not going to be that you can just look at it and solve it. You have to think about it and go step by step, and that seems to be the hardest for everybody in geometry. Okay, this one, because it's drawn, you have angles that are given to you, find x, then find the measure of the angles. So if I look at my two parallel lines that are marked, this angle here and this one here are corresponding angles. So I know corresponding angles are congruent. When lines are parallel, corresponding angles are congruent. So x plus 40 has to equal 3x minus 10. Subtract x, add 10. So 50 is equal to 2x, divide by 2. 25 equals x. I have now found x, find the measure of the angles. 3 times 25 minus 10. So 75 minus 10 is 65. Or 25 plus 40 is also 65. So I always double check that I've substituted into the problem correctly and solved it correctly, because they should both be the same measure, and they are. So you have solved the problem. The other thing I was just thinking I didn't show you is that when we have our parallel lines, our corresponding kind of make an upside down F shape. When you have your transversal and then your angle here and your angle there are corresponding. If we look at this one, this direction, this angle, and this one, so it makes an F with corresponding. Alternate interior angles are this angle and this angle, so they kind of make a Z shape. Same side interior they make a C shape. They are your supplementary. If we look at our alternate exterior angles, that one and that one, I don't know what we can make that into. We come up with what that is with this angle and that angle, then we have something. So we had our corresponding alternate interior, alternate exterior, and our same side interior. So we had an F, a Z shape, C shape, and our weird shape. So those are your shapes that go with 3-2, if that helps you see which angles you're talking about. Now you may start your homework.